Hello. Hi, this is JP. We're doing the show with Corey right now. He likes hacking low-level stuff, and his reputation precedes him. Corey, say hi to the folks.
Logic, Logic X. Corey just spoke, but
Okay, sorry. Sorry. All right, thank you. We're going to go right to Logic's video right now. Thanks. Sorry about that.
hello, Virtual Hope. I'm Eric, or Logic. I'm going to be talking about the emerging spectacle that is boot sector gaming, or more specifically, cheating at those games. You'll see video demos of the games, applying cheats to the games, and a deep technical dive into exploiting a weak random number generator of one of those games specifically. I also brought along a special guest of NanoChess. He's a talented programmer that's made many of these games that you'll be seeing, and most of the good ones. Also, finally, just don't mind the generic slide templates. This talk is mostly just showcase and demo content, so the slides don't even matter that much. Okay, so for just a general overview of what we're going to be talking about, we'll first just briefly talk about what a boot sector game is, and then we'll go over a video showcase of a lot of the games out there, about 25 games in total, and we'll do it real quick. Then I'll talk about what Boot Genie is and what it can be used for, and then we'll see a demo of some of the Boot Genie cheats for a handful of those games that we just saw. And then a real big portion of this whole presentation is going to be digging into Boot Rogue, a game, not only all the cheats, but how to really win at the game without using cheats at all. So real briefly, a boot sector is supposed to be a small bit of code that bootstraps your operating system. In this case, a boot sector game is, instead of doing an operating system, it's just a self-contained game. So you're limited to 512 bytes in the MBR boot sector area. It's machine code that loads into RAM and is executed after the BIOS routine. It loads into the 7C00 area memory, which may seem trivial, but when you're actually writing these, it does kind of matter for how you assemble it. It's 16-bit in its real mode, so ring 0. So that's some interesting different kinds of instructions that you might have to rely on and some that you can't use. And it must end in 55AA. It's kind of a signature. So that means your games are really actually limited to 510 bytes. And boot sector game, just to give some perspective here, this is what one would look like. We'll see this game later. It's the Cubic Doom game, which is like a 3D game. It's an amazing looking game for only being 510 bytes, and this is it. So now that we have a brief idea of what boot sector games are about, let's look at a showcase of what they really look like. That'll really visualize what I'm talking about. This is Tetris. It's a full-color Tetris clone. It doesn't have a score or anything, but it's one of the older boot sector games that is out there. And now we have another Tetris clone called Tetranglix. This one does include a score, but by default it doesn't actually have color. A significant contribution by NanoChess added color after the fact. There's a good write-up of this game found in an issue 3 of POC or GTFO. It's Tetranglix. This Tetris is a boot sector. It's kind of faster than Tetris, but we can see about messing with that later with Boot Genie. So this is Snake. It's one of a couple versions of Snake or Nibbles clone. It's just a basic, nice, clean Snake game. This is Petty Bird. It's one of two that I know of Flappy Bird clones. This one has pretty good physics, but not as good graphics as I think NanoChess's version, which we'll see. This is Tron Solitaire. It's like a one-player Tron a little bit, but a little bit like Nibbles. It has power-ups, has Snake strategies kind of. It's complex and has a progressive scoring system. It's also winnable, and it does require strategy to win the game. This is Dasher. It's a simple puzzle game with 2 levels. You slide from wall to wall trying to solve the puzzle and reach the finish. This is Boot Me, Crack Me. It's a polymorphic Quinn meant for the reverse engineer. At the prompt, enter machine code. This machine code is entered into itself, modify the program correctly, and you win. This is a game my friend made called Battle Snakes, my friend Goose. It's basically Tron, and it supports 2 players at once. He did his own keyboard handling for this one. It's pretty good. This is F-Bird. It's NanoChess's version of Flappy Bird, which I think has better graphics in my opinion. Expect to see a lot more from NanoChess with Boot Sector games. This guy's written a lot, and they're really, really high quality. This is Bootman. It's a Pac-Man clone. It has Ghost AI and Power Pills. This is Pillman. It's NanoChess's take on Pac-Man. Although there's no Power Pills in this one, the trade-off is much better graphics. This one is done in graphics mode. This is an Invaders clone, also NanoChess. It's in graphics mode, so it looks beautiful, and it's very playful and actually pretty difficult, although we'll fix that with cheats later on. This is a Boot Sector implementation of that 15-number puzzle physical game. This one actually also has an evil mode. If it boots up red, then it's not actually solvable in order. This is Validation. It's a social commentary game on the slot machine psychology of social media, like Facebook or Twitter. It's the least fun game to play, and the goal of it is to get a fixed minimum validation score before the timer runs out, like when your life ends. In this case, the timer is set to 2600. There's more story to this. If you want to read the GitHub description, it is more about the story of it. And there is a way to consistently win the game every time. I'm not going to say exactly how right now, but just think of the metaphor at how to actually win at social media, and that's how you'll win at this game. So this is Boot Rogue. It's a roguelike dungeon crawler RPG with HP, enemies, traps, food, swords, and armor. The goal is to get through all 26 randomly procedurally generated dungeons and retrieve the Amulet of Yondor. After that, you got to go back up all through those 26 dungeons, and once you get there, you win the game. This is probably my favorite Boot Sector game. This is one by NanoChess, and we're going to be putting a lot more attention to this game later on. This game's called Sorry Ass. It's a racing game with, I think, pretty clever use of the Code 4337 graphics here. This is Bricks. It's an Arkanoid Breakout clone. This is also done by NanoChess. And somebody had to make it. If he didn't, I want to do. I had another friend, John, that he was, I think, halfway done making one of these, but NanoChess, he beat all of us. This is Cubic Doom. It's a 3D raycasting shooter. You shoot all of the cubes in the room before they touch you and kill you, and try to get to the next level. It's one of the most impressive Boot Sector games from a graphical standpoint, and it was done by NanoChess. This is Lights Out. It's a Boot Sector clone of one of those old classic 90s puzzle games where you have to turn off all the lights. When you press it or select a light, all the lights around it toggle, as in above, below, left, and right, not diagonally. And yeah, the goal is to turn them all off. This game also does have an evil mode, so if the lights are all red, it's actually not solvable. And this is the winning screen that you're seeing right here. So here's another Snake clone called Snake in My Boot. The business logic of this was written in C, which is incredible in a way. The random number generator for the items is a little predictable, but the C just adds so much bloat. You can look at my fork for analysis. It's insane. And here's a Sokoban clone. I think it is just a really clean game with good color choices and character choices. The graphics look good for what this game is. And it even has wind detection, which I think is pretty good. This is 4 in a row. It's a Connect 4 clone, and it's meant to be 2 players. This is me just stupidly playing it against myself, but this is what it looks like. This game is called Follow the Lights. It's basically a Simon clone. It's like a memorization game. This is Toledo Atom Chess, written by NanoChess, or Oscar Toledo is his actual name, and it comes with AI. And finally, Dino, that T-Rex Chrome runner game, has good graphics and honestly really smooth gameplay as well. So now let's talk about what Boot Genie is. Boot Genie is basically like Game Genie, but for Boot Sector games, and it'll do cheating. It's patch-based and it's on assembly level, not machine code level, and that's for flexibility, so it can do multiple cheats at the same time. And doing these hacks and cheats isn't even really that hard. I know they're in assembly language. I know when you reverse engineer, you have to look at that. But in this case, it's source code, assembly source code. You actually have helpful comments to look at. It could be as easy as changing a variable, like 3 lives to 127 lives. So first, let's take a look at an intermediately challenging example with Tetraanglix. What we're going to do is we're going to slow the game down. So let's go ahead and take a look at the source code real quick here. We have a delay loop where we're incrementing bx twice. So we're adding 2 to it, and that's our delay, just adding 2. So to look at an example of a cheat or a hack to change the source code, we have adding 4 to bx. So that effectively makes it take twice as long, that delay loop. And that's it. You could also make everything a square. So instead of having challenging pieces, this is what all the pieces look like in the data structure here. And we just make them all squares. That's it. And this is what an actual patch file would look like for doing the delay loop. This is what the source of the patch file would look like. And here's the code for, or the command for doing the patch and even reversing the patch if we want to take it out. So the types of cheats I broke down into a lot of different categories, like more lives, make it slower, change the logic of the game. You could even make it harder, or your character can be invincible. We can do a lot of things, and we'll see a lot of that here shortly. So now let's take a look at what these cheats look like in action. We'll start with Tetraanglix, and for all these examples, we'll see all the cheats, but the ones bolded in green are the ones we're actually going to see a demo of. In this case, we'll look at the square patch. The time patch you can kind of understand. And then the other ones mostly are dealing with the scoring. Like there is a hard-coded set high score of 1,000 or 100,000 where the game kind of stops. We can set that to 1,000. And we can even make the score increment in doses of 255 instead of just 1 point. So let's take a look at a playthrough with the square patch. All right, so for each of these demos, I'm going to go through the whole process of git cloning the original source, going to the directory, assembling it with NASM, and then just playing the original real quick just to show the original state of it with QEMU. So we've assembled it, and now I'm just going to run it with QEMU real quick here. And this is Tetraanglix in its original form, without the color or any of that stuff. So just maybe do one line of this, and then we'll go to boot Genie. All right. So what I'll then do for the rest of this and the rest of the videos is I'll go ahead and list out all the cheats for this particular game. So I got to go back to the directory and do boot Genie and just kind of wild card for Tetraanglix here. And those are the patches I can apply for Tetraanglix. And like I said, for this one, I'm just going to do the all squares patch. So I'm doing the patch, and then boot Genie and Tetraanglix square. Let's go ahead and patch it. And then now I do got to reassemble it because I'm patching the source, not the game itself. So we reassembled it. Let's play it. And this sort of looks like square, square, square. I'll do a couple lines. I'll fast forward it here in a second. Just to show the ridiculousness of this, but yeah, all squares. There we go, fast forwarded. See that? Really, if you want to rack up high score, this is probably a quicker, better way to do it. Just keep those up like that instead of bringing it all down like that, but yeah. For invaders, we can overall slow it down, but instead it'd be more interesting to give us so many lives we're practically invincible, and then we'll make the guys advance down a third of the distance each time, giving us ample time to take them out. Let's take a look at that. All right, let's go ahead and clone invaders here and go to it, build it, run it. And this is normal invaders, normal gameplay here. It's actually pretty challenging in my opinion. All right, now let's start doing boot Genie to it. I'm gonna do the extra lives patch and then slower advancement patch here. Go ahead and play it now. And just watch real quick how they advance down. Right here, barely any, and with 127 lives, I don't have to worry about getting shot. So here's the game sped up a little bit, and I'm still not playing perfectly here, but as you can see, it's still a little easier. We can make it really easy to get a high score with boot Genie in F-Bird. We can make the clearance between pipes really large so we don't hit them as much. We can add a whole bunch of pipes to get the score quicker, and we can actually make the game faster. It won't make it more challenging in this case because the pipe clearance is so large, and we just rack up the score even quicker that way. So let's take a look at that. All right, let's go ahead and clone F-Bird. Go to it, assemble it, and play it in its original state. And this is what it looks like here. It's not too bad. It's kind of challenging, but still possible. All right, let's do our first patch. We're going to kind of do these one at a time here, just to show the differences as they build upon each other. So we're going to do the pipe patch. Let's go and play this. So what this does is it gives that extra clearance. So now it's just super easy. But I mean, it's kind of more boring now just because it's kind of slow and all that. We want to rack up that high score quickly. So we're going to add another patch here. More pipes. So when we do this, you'll see they're not so far spaced apart. See how there's a lot more pipes there, so we can kind of rack up the score a little bit quicker. So that's cool. But one more. Now, the game plays really, really fast. And this actually reveals something that most people probably wouldn't see if they play the game naturally. Once we get past a certain point here, we're going to go into like no man's land or whatever, where it kind of goes back to without what it looks like without the cheats on some parts. I think it's about like after score 120 or something like that. We'll get there in a minute. All right, we should be close now. There we are. So there's a lot of ways we can cheat at Tron Solitaire. First, we can make the initial score really close to the score to win the game. We can make the game slower. For the other speed hack, we can make the game not progressively get faster. We can do no clipping, which is basically invincibility. We can set the score required to win the game much lower, so we just get to it quicker that way. And then lastly, we can set every item to not be poisoned, so they're all power-ups, good power-ups. For this, though, for the demo, we're just going to look at the speed patch. We're going to make it really slow. All right, now with Tron Solitaire, we're going to grab it, assemble it, play it. This is kind of what it looks like in real time. I'm just going to play it until I see a green apple, as they're called, instead of these red poison apples. A lot of poison. There we go. So there's a green apple down there. All right, we're good. Now let's do a speed patch to it, make it a lot slower. So this is how unplayably slow it is. It's kind of boring. So obviously I'm going to speed up the video. But this game is slow enough to where I can beat it more consistently. Like I have beaten this game without any of the cheats. But when it's this slow, it's easy enough to consistently beat it. So let me speed it up in a second here. There we go. And you can see the score down there. It's in hex, whatever. And every like 4,000 hex, the game naturally speeds up on its own, unless you add the other speed patch to where it won't do that then. But we're not going to use that. You don't really need it. So we're almost up to 6K. There we go. Getting close to halfway there with the 8K. And the game will get ridiculously fast at that point. Yeah, past 8K. We're about to win. Almost there. Just trying to avoid all the poison apples, but it gets hard after a while. There we go. We won. That's the flashy win screen that we get here. For Bootman, we can play in a completely different level. We could even be invincible, but for the purpose of the demo, we're going to make it really slow, and then we'll do the strong pill patch, which makes the ghost run away for a lot longer. In fact, you can go from pill to pill and not have the ghost attacking you at all that lasts so long. So let's take a look at that. All right, so let's look at Bootman right here from Guy Hill. We're going to go ahead and git clone this. All right, we'll go into the directory, and then we're going to build it or assemble it. And let's play it real quick just to see what it looks like in its original form. So here we go, just playing through a little bit. Not really doing much. I'm dying. All right, now let's just take a look at the collection of cheats. Look at our catalog. That's what we got to pick from. So first one we're going to do here, just going to Bootman, do the speed one to make it a lot slower, although the video will speed it up when we get to that. And then the strong pill one so it lasts longer. Let's go ahead and rebuild it, reassemble it, and see what this game plays like now. So it's stupid slow. I'll speed the video part up. But then we'll go into one of the pills. Here we go. And you just see how they're like that forever, you know. So I'll just go through and play to win. The pills last so long that it almost persists until you get the next pill. It's ridiculous. So there we go. And we've effectively won. The snake cheats are pretty straightforward. Just slow, way slower, and unplayably fast. And we're going to take a look at the slowest in our demo. So finally, we'll take a look at snake. We're going to grab it, assemble it, play it. This is what it looks like at normal speed, which is actually kind of fast. It does make it challenging at this speed to play it pretty far into it. So we're going to do the speed 2 patch. We're going to make it almost unplayably slow. So this is at normal speed how slow it is. So I'm going to speed it up here in a second. And really, I'm going to play it to completion. I'm going to play this until I fill the whole screen up. So I won't bore you with that at this speed. It actually, in real time, this actually took almost 2 hours to fill up the whole screen. So I'll only bore you with maybe another 30 seconds of this. But here, it's going to speed up a little bit here, progressively. I think at about score 50, it really takes off and will blind us here. And that's the way I like to play Snake or Nibbles. The goal to quote-unquote win the game is to completely fill up the screen. So here we go. Now it just rockets. I know, dead air. Whatever. And that last little bit is what you kind of have to do. And then finally, we'll take a deep dive into the last game we're going to talk about, which is Boot Rogue. So instead of describing this game myself, I'm going to let NanoChess himself explain the game.
Hi everyone, Eric invited me to explain why I have developed Bot Rouge. In 1989, it had access to a televideo PC. It was a machine with all integrated monochrome monitor, 514 floppy disk, 10 megabytes hard disk drive, and CGA video card. Having software for that machine was very difficult. There weren't software stores in my area, so I depended on a friend that sometimes brought me game discs, labeled very informatively as Games 1, Games 2, Games 3, and so on. My favorite game at that time was Boshero, a game where a karate guy kicks ninjas with swords that also throw shurikens. With no manual, I discovered the case that changed the player modes. After playing it so much, I got bored, and the next game was Rush. This smiling face always made me think, "What's so happy? How can he be so happy in the unknown?" I started to move this melee through the maze, and with the help of OFAT, Simon Schuster English-Spanish dictionary, I started to translate the message, and then my mind surprised. Oh, he's fighting with monsters. Oh, the armor glows. Damn, that ring cannot be removed. What? He died from starving? With no doubt, Roche was the game with more content I never had played. But I did knew the objective. I killed monsters, I started ascending more of things, and then I found it, the gender's amulet. The first time I didn't know it was so special and kept descending. The next time I started going up, and then whole squadrons of monsters fell over me. In a certain moment, I felt like a desperate kid fleeing from the dungeons with my treasure. And I made it, and I jumped euphorically. Probably that euphoria was what I remembered when I started to quote Roche. The Roche memories had me searching information about how to generate the messages, and I found a simple description, a 3v3 grid with rooms connected randomly. It was the first thing that I implemented. Then the smiley, the stairs to descend into the dungeon, the gender's amulet, and the light circle. I blocked so good that in a few days also added monsters, weapons, armor, food, traps, and then used a lot more time to keep reducing the code until fitting the size of a boat sector. Everything in Boat Rouge is a homage to Roche. If someone told me I will end in making a 512 bytes Roche 30 years into the future, I will never have believed it. Then Eric wrote me a message. Please don't change that random number generator. It is genius. Thank you. Greetings from Mexico.
And that was NanoChess. And by the way, he actually has a couple books on boot sector programming. Follow him on Twitter to find out more. It's excellent. So the irony here is I gained a huge advantage from learning what I learned from doing the cheats without actually using the cheats. This led me to write a 140-page game guide for the game, like a strategy guide. And you'll see some excerpts from it down the road. I haven't published it yet, but it is coming out soon. And really the goal of the game is to win it, sure, but I guess high score is another goal. So winning is easy enough with enough patience. So my main goal started to get targeted on getting the highest HP. We'll get there, but the first thing we're going to look at is one of the cheats. It's called Magic Lantern. It's one of my favorites, and this is one of the ones that really opened my eyes up to all the patterns and advantages that I now have. So real quick, this is what it looks like to play with Magic Lantern on. I'm just going to go and get what I want here because I can see it all. And when I go to the stairs over here, well, I'll get that sword first, but when I go to the stairs, you're going to see the next one. So to talk about patterns real quick, let's take a look at one of the dungeons full view here. We're going to look at the armor and the food. I'm going to highlight that here for us so we can zoom into what we're looking at. There's 1, 2, and 3. And you notice they're spaced the same distance apart. It's pretty consistent. What's a little bit less obvious, though, is the sword and the gold here. But it is consistent. It's just one of them has to span, at the top has to span, from one row to the next. Sometimes it's one room to the next, but it shows you not only that there's patterns, but kind of how the whole dungeon is procedurally processed when it lays the items out. So things seem a little too predictable. I want to look at what affects random, how random's created, and this is pretty much it. There's the 4 lines of code here at the top are what's really doing the magic. The rest of it's kind of some processing it to get it down to like a dice roll format, but really it's these 4 lines of code. Now, there's only one other line of code that affects random, and that's how the staircase is laid out to decide which corner to put the stairs in. And that's just the shift instruction right here. That's all. So this is all there is to it for how random is done. So now I'm really interested into what these numbers look like what the entropy is, all those kind of things. I want to do some analysis. So what I do is I use Python scripting to automate the GNU debugger. What I do is I set a breakpoint at where the RNG number has been generated and log them to a file. And I've used a similar process to malware actually in my real life on systemd miner. And this allowed me to figure out what it was actually doing before I knew what it actually was. And I was logging different things, but same kind of idea, breakpointing key areas and getting the data I need. So I'm just going to demo this here. You can see the code in the back there for the script. It's actually pretty simple in this case. So I just need to go to where bootrogue is, and I'm doing GDB with -x to run the script that I want to run with it. And I'm just playing through the game so it can do its thing and log the random. And then I'll run a couple of stupid bash commands just to show what the numbers look like to some effect, but really my analysis was in reality pretty manual. And what I found was for the first, say, like 400 to 500 calls to random, it seemed pretty random, but then after that, it sequenced through 128 distinct values, like it was looping. So that's the lesson from this is, and then for whatever reason, there's 128 values that it just loops through one after another and just repeats. Pretty interesting. So there's that 128 there, just showing the distributed amount of numbers. So now that we know that we have a very small closed loop of random values, it might be worth knowing what kind of things we can do to affect that loop, to advance that loop. It boils down to 7 things. One of them is battle, attacking and defending. The door will affect it. If you land on a trap or if you eat some food, that'll affect it a little bit. And what massively affects it is generating the dungeon itself. The max width and max height, those 2 things will affect it as well. It makes several calls on random. So in English, food makes a call, traps make a call, door placement makes a call, the process of battle makes several calls, and dungeon generation will do hundreds of calls for one dungeon. So let's make some assumptive jumps here. There are only 128 8 unique dungeons, because that's the only amount of random values that we have to start a dungeon generation. If you know the RNG state when you're starting a dungeon, you should be able to calculate what the next dungeon is going to be able to be. You can affect the RNG state by getting food or hitting traps and encountering battles, but we'll only do food and traps because battles are a little bit unpredictable. But really, the assumption is we can actually predict and affect the next dungeon that's loaded. So again, you can choose the next dungeon is what this boils down to. But let's revisit patterns. You remember when we saw the food and the shield so close next to each other? Well, they do have a cycle. We see the shield at the top, then we see one floor tile, and then we see food. But if you count another 17 tiles, you'll see an enemy after that, and another 34 tiles, you'll see gold after that, and so on. And it actually loops. And that loop, if you add all these numbers up, including the items, it turns out to be a total of 128. So, no mistake there. This is actually starting to make a lot of sense. I also noted that there's 124 unique types of rooms. I started cataloging all the different types of rooms that I saw in full dungeons. And yeah, it turns out that there is a finite amount of types of rooms, including the types of items that show up in them. And go figure, they follow in ordering as well. If you know one room, you can predict the room that follows it over to the right-hand side of it. So I mapped it out. The orange rooms are just general ones. The green ones are rooms as starting points, so there's no room to the left of it. The purple ones are rooms found in multiple sequences, and then that blue circular area down there is a loop. So once you get in there, you just keep on looping around. So for example, we'll look at Dungeon 1. It starts at room 41, and then you go to 42, 14, 17, 14, 9, 10, 3, 7. That's the different 9 rooms that Dungeon 1 is made up of. That's how this map works. So to step up a layer of abstraction, I started cataloging all 128 dungeons, and this is kind of the anatomy of a dungeon. You have the dungeon number, the seed, that if you give it that RNG value, that's the dungeon that will be produced. And then I show the top 10 exits. So like if you did nothing, you would actually go to dungeon 28 if you just went straight for the ladder. But if you say hit a trap or got one food, you would actually go to dungeon 29, and so on. For every RNG thing you affect, that's the next dungeon you're going to hit on. I also gave an identity dungeon in green there. That's how many items you'd have to get in order to arrive back at Dungeon 1. And at the very bottom, you see that room sequence, as we covered on the last slide. You also get the amulet location in purple there for if this were level 26, that's where the amulet would show up. And then off to the right, you see all the dungeons that are the most likely to be coming from into Dungeon 1. Naturally, the next thing to think about is routing. If you want to get to your favorite dungeon, you can get from any one dungeon to any one other dungeon, but it might cost you. It actually makes way more sense to route through multiple dungeons to get to your gold dungeon, because it'll cost you a lot less in HP because of all the less amount of traps you have to hit. But routing's hard. It's actually a computer science thing. Like I actually had to end up writing a script to solve this problem for me that used recursion and all other kinds of other crazy programming crap I hate doing. But we'll talk about that in a bit. And we'll talk about it in the context of getting from point A to point B, and in this case from Dungeon 42 to Dungeon 1. We'll look at a demo. So I'm going to show you a demo of the Pathfinder script that I wrote for this. We manually hacked the game to start at Dungeon 42 just to demonstrate this. So this is the path from Dungeon 42 to Dungeon 1. This looks a little cryptic, so let's walk us through it real quick here. We're on the game. We're on Dungeon 42. To get to the next dungeon of 51, we need to get 1 food, 2 traps. So you see I'll go through the food here, get 2 traps, and we'll exit. And then in Dungeon 51, we need to get 2 food, no traps. To get to the next dungeon. So we get our 1 food, 2 food. There we go. Now we're on Dungeon 3. We only need to get 1 food, no traps. So let's go over there, get our food, exit. Now we're on Dungeon 1. So that's one way to get there. That's the most economical way to get there. But now I'm going to do an argument to the thing here. So 128 item depth. That means consider all paths. Well, I got to do it right here by adding Python to the beginning. But anyway, so we run that. We get our direct route. Got to do 81 random calls just to do that. So this is where we're going to apply a patch to make it so, let me put this in here. There we go. So we make it so the good items don't disappear. So instead of going on traps, I can just go over the food. See, I went over it twice already. Now I just got to go over it 79 more times. Speed that up. There we go. And then once I'm done, I can go for the exit, and I'm done on Dungeon 1 again. So that's how that works. Now for a quick tangent to a side project called BootMage, it's going back to putting Python into GDB, but in this case, we're doing a live dashboard while we're playing the game. It shows us internals to the game that we wouldn't normally be able to see, that I'm sure NanoChess would have displayed if you had more than 512 bytes, but now we can extend the game for higher visibility, and we'll see a demo in that here in a second. Just catting out the script here. This one's a little bit longer than the other dumper. It's quite a bit of stuff there, actually. So we're just going to load up with boot rogue. The game started, and we'll start to move around, and you can see a little dashboard up there. The cool thing about this is you do have a hunger, so as you move around, you will lose HP eventually. It's actually every 128 steps. Well, in the upper right-hand corner, you can actually see where you stand with that. So once that counts down all the way, you'll know you're going to lose an HP, which is pretty cool. You also get how many items are in each room, and it'll count down. It'll actually decrement as you get the item. And you also get some internals like your current attack and defense when you collect armor and swords, which you wouldn't normally know. And you also get to track money, which the game couldn't do because there wasn't enough space left. You know, Oscar just wanted to add the money in there for just to have it. You know, and then this is us engaging in a battle. We actually get to see blow by blow when we get into a battle how much HP everybody has, how much they're attacking each other for. It's pretty great. And then we even get what our current dungeon is, what the next dungeon would be based on the items that we're getting, and even a tip of what the next dungeon should be that you should try to get to, which is based on what we'll get into here in a little bit. But then, you know, even when you play through the entire game, after I'm just going to kill myself here real quick, you get some endgame statistics. It's beautiful. But now we'll talk about how to get the high score. So anyway, getting back to this, we know we can do routing, but we don't really know what the best route is or what the best dungeons are. But one cool thing about the Pathfinder script is it doesn't do loop checking in this routing. That's advantageous in this case. So if we hypothetically said I want to go from dungeon 1 back to dungeon 1 and do it in 7 or 8 hops or a lot of hops, or, you know, dungeon 30 to dungeon 30 or whatever, if we do this for a lot of different test cases, then the most efficient routing or the best dungeons we should see showing up somewhere in the middle quite frequently. So let's take a look at some of those examples. In this case, we're looking at from dungeon 1 to 1, or 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6 to 6, and then 12 to 12, 13 to 13, because some of those other dungeons aren't really routable as easily. But I highlighted in green the patterns that we were looking for. So dungeons 1 and 31, those are the best dungeons, and there's a reason for that too. Dungeon 1 is a dungeon that has 3 food in it, and there are other dungeons that have 3 food, but not that many. But the cool thing about this one is if we get all 3 food, we get to another dungeon that allows us to get back to that dungeon in 1 hop, and we consume all the food, which is just 1 in dungeon 31 as well. So there's no other dungeon that has 3 food that allows us to get back so quickly. That's why the dungeon 1 to 31 pair is the most efficient. That's what you want to be doing for the entire game once you get to one of those dungeons. So if you want to get the high score, the highest HP, you first identify the dungeon you're in, and then you use a best path to get to either dungeon 1 or 31, and just keep alternating those dungeons till you get the amulet and back, and you'll have a lot more HP than otherwise. So what's the best way to identify the current dungeon you're in? I mean, I do have a catalog and you can explore the whole dungeon without touching anything, but the most efficient way possible with the littlest bit of movement is to identify the current middle room, and then from there use the sequence patterns in previous slides to identify the southeast corner room, and then from there on the next slide I have some diagrams that if you know the southeast corner, you can pretty much know what the next dungeon is going to be. You might not know what the current one is, but you will be able to know what the next one is, which is perfect for routing. So let's say that we're in room 8 for the southeast corner. Then we would know if we didn't touch anything that the next dungeon would be 68. I mean, if we got 1 food, then it'd be 69 and so on or whatever. Or say we were in room 12 for the southeast corner, then the next one should start at 104. And that's how this guide works here. So as a reference, this is a full playthrough of Boot Rogue. I'm going to speed it up here in a second, but my strategy here is to just get every food item and, you know, swords or armor on the way. But the idea is to try to maximize HP by getting as much as food as possible, no matter what the routing may or may not be. And here I am on level 26 getting the amulet. Slowed it down for that. And then I'll go all the way back up. Speed it up here. And at the very end, we'll have about 100 or so HP, a little over that, 116 HP clocking in at. We're now going to use everything we've learned to do a full playthrough of all the strategy to get the highest HP possible. So now we've identified the middle room. It's room 18. We're going to use that to identify the lower corner. It's 18, 32, 14, 9, 10 by room routing sequencing. So that corner would be 10 based on this. Room 2 or 10 is 10. So the X would be 60, which is similar to all these dungeons. We're just going to go off of dungeon 5 for the Pathfinder tool. So for Pathfinder, it's 5 to 1. That's a 3-hop route. 5 to 3 1 is only a 2-hop route, so we're going to use that method. So for the first hop, we got to do 2 food and 1 trap. So that's what we're going to do here. And then we'll do 2 food, 1 trap again for the next one. So there's 1 food, 2 food, 1 trap, next one, and then 1 food, 2 food, 1 trap. And then we're on dungeon 31, and we're just cycling between dungeon 31 and dungeon 1. We'll do that all the way till we get to the amulet. I'll slow it down for us once we get there. You can see we're at level 18, 19, 20. It's coming up pretty quick. All right, here we are, going down, getting the amulet. And we'll speed back up and just crank all the way back up to level 1 until we win. So just remember the first playthrough where we're trying to get as much food as possible, just ignorant of which dungeons we were in, we got like 120-ish, for 116 for our HP. But with this, we got 411. That's almost quadruple, just by knowing how to route through the right dungeons. Before we conclude, one last thought is why 128? That seems a little too neat, right? And even though the algorithm seems to be 16-bit, we'd expect like 65,000 values or 65,535, but it really seems to be effectively 8-bit. But that would still be 256 values, not 128. So why is that? Well, it turns out there are 2 separate 128 value loops, and they're mutually exclusive. There's actually a 50% chance that we see that other loop in the first dungeon, but if we do see that loop in the first dungeon, the next dungeon will be the loop we are used to. But say the 50% chance we end up starting on the loop we are used to, well, the dungeon 2 or the next dungeon will be, again, the loop we're used to. It's only one way. From that weird loop, we always, on the next dungeon, get to the loop that we are expecting. So why is that? Well, that has to do with how the ladder is placed. That one weird shift instruction will mess that all up. So why does it go from one loop to the next but not the other way around? Well, that has to do with an unusual parity issue. And it just, the rabbit hole gets even deeper from there. And I have a pretty full analysis on that in my strategy guide, which will come out soon, and I'll mention it on Twitter to announce it. But yeah, just little things like that. The behaviors that can emerge from a 512 byte game, as you've seen with all the other things, is pretty amazing. So that brings us to the end. Here's all the GitHub projects. There's Boot Genie, the Rogue Routing, Boot Mage, and then that gist is all the 25 Boot Sector games with GitHub links and descriptions. And really, you can just go to my gist, and it's the only gist on there anyway. That's my Twitter. You don't have to follow me. It's just where I will announce that Boot Rogue strategy guide once I get that published. And that's pretty much it. At this point, this is where I guess I'll be live and taking Q&A and discussions or whatever. We can just chat for the next 10 minutes or however much we have.
You're live, JP.
Okay. Hi, we're back here with XLogic, and we have a few questions. In fact, there was one that was just posted about JS Linux, and I was going to ask XLogic if you've had a chance to try that out with your work.
No,
No.
the stack I use doesn't. Yeah, I haven't tried that. I mostly am in QEMU and use GDB to debug. Whereas NanoChess, he uses a completely different stack. Whereas I'm in Linux with GDB, QEMU. He's in Windows, and I forget what he does to debug. But I think he actually has a different strategy. It's kind of interesting to go into that. He starts with his programs as a COM file, so he can like bloat them out to be larger than 512 bytes. So he'll try to write it with all the features and then optimize down. Whereas with me, I'm stuck with 512 bytes. I write as much as I can to make a functional game, and then I'll optimize down to add more features as I go, which is probably a worse strategy. But yeah, there's a lot of ways to do the same thing. But I haven't used that way.
Okay. I think we got a question from Greg. how would you describe some of the data structure that you use to represent the games? So, as arrays or individual elements.
That's game by game. You do whatever you can to optimize. For some things, I mean, you can have, say, like a sprite, and I might represent them as 2 colors, so it's 1 bit per pixel. Yeah, it really depends on the game. Sometimes you have certain elements that are directly in memory, and you're modifying them on the fly. There's a lot of different strategies and ways to do it, but I think that the most general way I could think of it is it just depends on what saves the most bytes. And we do some crazy stuff to save bytes. The code, though it's commented, could be pretty unreadable because of that. I'd say it's all on GitHub. It's all open source, and I don't want to be the guy that says, read the code. But one cool thing about boot sucker games is that being that they're only 512 bytes or about a couple hundred lines of code, it's really manageable or digestible to read the code. And you'll also notice that once you read all of our code, it's you get a feeling that it's a little bit tight knit because we all use the same tricks. It's great. If you're into demo scene kind of stuff, it's right up that alley. But as far as data structures go, anything.
Got it. All right, I have another question for you. Do you like to use actual 8 or 16-bit chips for this kind of work?
Well, so boot sector programming is 16-bit specifically. So I mean, I'm emulating it myself. About like half a year ago, I did end up buying an old Optiplex that had a actual floppy drive in it, and was doing that off the floppies. But I mean, it's, I wouldn't even say it's like I think the processor might be 32-bit or whatever. But I mean, again, this is 16-bit programming specifically. And as a little tidbit or off to the side, not related to that question directly, but I started getting into this because I wanted to learn Ring 0 programming, which is what you're in. You're Ring 0 when you're doing this, which is cool. I wanted to learn more about that. But then I quickly learned that it's actually pretty boring. It's super boring. But the way I learned Ring 0 or learned how to do that was from Tetranglix, actually. I learned about it from POC or GTFO. So that's what got me into it. And when I realized Ring 0 programming was boring, I was like, well, let's just make games instead, which is way more fun.
Got it. All right, I think we have time for a couple more questions. Did you ever try an FPGA for some of your ports or game work?
Not for this. I mean, I've done stuff with FPGA. Really, it's been so long since I've done stuff with that kind of technology that back then they were called CPLDs. I mean, it's a little bit different, but computer programmable logic device. It was literally decades ago since I messed with those. But no, I haven't done any games with FPGAs or that kind of technology.
Right on. All right, I got one last question here, and actually, it was from L Ball. How many pages are in the Boot Rogue strategy guide that you're working on?
Yeah, that's Eyeball. He's probably being a shill right now, but it's 130 pages. 130.
Oh, very nice.
Which most of it's because there's the dungeons. There's maybe like 2 dungeons to a page, so a lot of it is not so much like content and words, but just a lot of graphical information. And I know with the talk, it seems like at the end I flew through that. Some of it might have been sort of incomprehensible. And it's because, there is a little bit more context to it. But with the book, you can kind of slow step through and really understand it all.
Very good. Well, I think that's all the time we have right now. We want to thank you very much for being a speaker here at this show. And if you have a couple of words you want to say to everybody or anything before we go.
Thanks for having me. Thanks for listening, and join the Boot Sector gaming community. I want to hack more games.